All right, these normal distribution questions are much better. We draw a picture. So let's go ahead and brush. Not the most graceful drawing, but it'll work. So we have a mean weight of 4,000 and then we have a standard deviation of 266. So this looks like a question from chapter, what was it, 8? The difference here is we have a mean of a sample of 53 babies. What this really affects is the standard deviation. Instead of 266, it'll be 266 divided by square root of the sample size. So this will give us, let's do a real quick Google here, 266 root 3, so 36.54. So 36.54. Okay. So the question here is, what's the probability that the mean weight would differ by less than 45 grams? So what we're saying is we're sticking close to the mean. Differ by less than 45 grams means that we're going to be in this area right here. Point, it becomes a question from 8.4. We would, this goes up to 45 grams. This goes up to 4,007. And this down here would subtract 45. So this would be 977. Those are the x values there down below, and we just need the area in between these. Using this as our standard deviation instead of the 266. So we would we would do it with both of them, but let me just do one here. 7 minus, and we're subtract the mean, 4,022, and then divide that by 36.5. Okay, we would get this z-score and then look it up on the table, and this would give us the portion to the left. If we do take a peek, well, let's see. So the Q page, looking in the tables. So the first table, negative infinity to negative z, gives us everything when z is on the left side. But if you see in our picture here, so that's the table we'll look this one up here, because this is on the left side of the mean. But what we're looking up right now is this 4,067, and that one's on the right side of the mean. And we get a z-score from it. Maybe that, so that'd be 45 divided by 4. $1.23 score. So I'm just looking for 1.3, and that would be 0.8907. And the way I know which table to look at. I mean, I can see the picture here. Notice this matches what I'm looking for. I'm looking for something on the right side of the mean, whereas the next one, the left side of the mean. But both of them are giving me the area to the left. Okay, so 1.53, sorry, 1.8907. That would give me everything here all the way to the left. So the reason we're not done is we only want the area that's shaded black. We only want the area in between the and that's why we have to end up subtracting out a portion because we don't want to include it. The table gives us that. The table gives us everything to the left of our z-score right here, but we don't want everything to the left. We only want the black shaded portion. So how do we know what portion to subtract out? That's where we use 3977. We plug it into the same equation over here, get a z-score, look it up in the table, and whatever that portion is, we'll subtract it here to give us the portion in the middle. One thing just to point out, we can also see, yeah, we'll stop it there.